We were looking at this exercise 3.98 from the text. So here we want to do parts F and G, where we want to look at whether the two events that we're discussing. So here we were essentially interested in two events. Let's just recall. So we're interested in these two events. M, this is something we looked at earlier. The analyst has MBA. O, analyst is over age 35. So we want to do part F and G now. So part F asks us that are the two events MPA and over age 35 mutually exclusive, right? So in part F we want to see are M and O mutually exclusive. For this, let's recall what do we mean by mutually exclusive events. So recall two events A and B are mutually exclusive. If we know A intersection B is equal to the null set, the intersection is equal to the null set, and so probability of A intersection B is equal to 0, right? Because we know A intersection B is equal to the null set and probability of null set is 0, right? So mutually exclusive events, the probability of the intersection is the null set, and the probability of that intersection, which is the null set, is equal to 0. In this case, so let's apply this in the specific case. In the specific case, probability of M and O is 0.105. We found this in part A, right? So this is actually from part A. So we found this in part A, the probability of the intersection when we apply the multiplicative rule. So this is from part A. We've already found the probability of the intersection, which is not equal to 0. So O and M are not mutually exclusive events, right? So their probability of intersection is not equal to 0. So they're not mutually exclusive. So whenever you're looking at whether two events are mutually exclusive or not, if they are mutually exclusive, the intersection should be the null set, and thus the probability of the intersection should be 0. In this case, the probability of intersection of M and O is not equal to 0, so they're not mutually exclusive. Now let's test our, let's do part G. Are M and O collectively exhaustive? We want to now look at part G, which says are M and O collectively exhaustive? Let's first recall what do we mean by two collectively exhaustive events. So recall two events, A and B are collectively exhaustive if A union B is equal to the sample space S, and so probability of A union B is equal to 1, because A union B is the sample space and probability of the sample space is 1. Now in this case, probability of O union M is 0.645. This is what we did in part C. In part C, we found the probability that the randomly chosen analyst has an MBA or is over age 35, and we know or means union. So in part C, we actually already found this probability. So this is from part C. So probability of O union M is 0.645, which is not equal to 1. So O and M are not collectively exhaustive, are not collectively exhaustive, right? So remember, if you want to see whether two events are mutually exclusive, the intersection should be the null set, and so the probability of that intersection should be 0. In this case, we found the probability of intersection of O and M is not 0, so they're not mutually exclusive. If two events are collectively exhaustive, the union should be equal to the sample space, and so probability of the union, which is the sample space, should be equal to 1. In this case, we saw the probability of O union M is not equal to 1, so they're not collectively exhaustive.